And we're back.
No, but
For those, okay, so what did you miss? You didn't miss anything. Next slide. Okay, so when we raise e to an imaginary power, what do you think happens? Okay, so now, wait, actually go back to the previous slide. So if you notice, it actually looks kind of like the exponential function in that they're consecutive numbers. But in the sine function, they're only consecutive odd numbers, and in the cosine function, they're only consecutive even numbers. Now, it kind of looks like you might be able to combine them, except for the fact that they're all positive in the exponential function, so you can't really prove that it's equal to sine plus cosine. But you can prove that slide. Well, you'll prove something. So what happens when you raise e to an imaginary power? Because you might be able to get to combine them by raising it to an imaginary power. So slide, yeah. So this is just our exponential function we had. Press it again. So when you raise, Jared. So when you raise it to iq, you replace q with iq, and you get something like this. So e to the iq equals 1 plus iq plus iq quantity squared over 2 factorial plus iq quantity cubed over 3 factorial, and so on and so forth. And if you remember from our properties of properties of the imaginary unit, that I squared equals -1, and I cubed is -I, and I to the fourth is 1. So really, this should follow a pattern. This should follow the same pattern that the powers of I do. So Jared, so if we simplify it,
powers of yourself.
powers of I. So if we simplify it, you notice it becomes e to the iq equals 1 plus iq minus q squared over 2 factorial minus iq cubed over 3 factorial plus q to the fourth over 4 factorial plus iq to the fifth over 5 factorial. And so if we separate the real and imaginary parts of this series, we get, next, we get e to the iq, and this is the real part, this is the imaginary part, right? E to the iq equals 1 minus q squared over 2 factorial plus 4q to the fourth over 4 factorial minus q to the 6 over 6 factorial. So notice that the evens are real and alternating in positive and negative, and you might be getting kind of excited if you see where this is going. Anyway, and the imaginaries over here, we factor out the I, we get the odd powers over the odd factorials. Okay, you see how that works? So now, if you remember your,
Wait, how do you get from e to the iq equals 1 plus iq minus blah blah blah?
So you get from here to here. Basically, what you do is you take all the real ones, and you put them over here, and there's a dot there because it's an infinite. And then if you ever reach the end of that infinite, see, you also get, so I times q minus q cubed over, so these are the imaginary powers, and you're factoring out the I, and you're just putting all those over here. You're sorting is what you're doing. You understand? You're factoring. So, and now, if you remember, this is the same as the cosine series that we saw earlier, right? It's the even powers over the even factorials, and this is the sine function. It's the odd factorials over the odd, or the odd powers over the odd factorials. So, so this really, if we just replace these series with their functions, you get something that's really quite profound. So, Jared? Oh, yeah. So we have that, and then, so remember, this is your sine function, Jared. That should be 1 again. Okay, I'm not going to change it, but yeah, that should be a 1. That's a 1. Okay, Jared? Next thing. So then you just replace these, and you get e to the iq equals cosine of q plus I sine of q. That is, if you raise e to an imaginary power, you get cosine of q plus I sine of q. You get the trigonometric functions, and in fact, that's just the identity that we got back when we were looking at those polar forms of complex numbers. And if you raise e to the I tau, you plug in tau for q, what do you get? Here, next. So e to the I tau. So cosine of tau is is just is the same as cosine of 0, and that's going to equal 1 because the side length on the unit circle is going to be 1. And then sine of tau is sine of 0. That's just 1 because, or sorry, that's just 0. So there is no imaginary part. So e to the I tau equals 1. That is 3 of the most fundamental constants in all of mathematics. And actually, if you do e to the I pi, you get -1, which some people think is less beautiful. I guess. And then 1 is unity. If you raise, so e to the I tau is unity. And as Salman Khan said, if this does not blow your mind, you have no emotion.
It doesn't blow my mind because I have no idea what it is.
Oh, okay,
Yeah.
so.
Basically, the
My fault,
fact
not
that you
yours.
can take together 2 irrational numbers and I and get them to equal 1, a whole number,
Yeah, this is
just in itself.
another
is
thing he
incredible.
said was that
Yeah.
this
And the fact that it's
suggests
1 makes it more incredible.
this suggests some kind of continuity to the universe, something because really we defined all 3 of these things separately to be separate things, and yet when you put them together, it equals 1. So it's just humans have at least done something right.
Once you get tau,
Tau? Tau is 2 pi.
Yeah, but why are you
yeah, but
still
where did you
doing
get
Q
that
for
from? Cosine q plus I sine.
Well, you're just okay. So these
So he's
are
not giving, you're just saying that if Q is tau.
yeah. You're just
Oh, right,
substituting
because
that.
Q is just very
Oh,
like, right.
yeah,
He's
it's
using
very
Q.
Yeah, I should have used x actually. That probably would have been clearer. Or z.
But
Sorry about that.
cosine of tau times I
Plus
sine
nine,
tau
yeah,
equals
plus
1.
Oh, that is cool.
Yeah.
Yeah.
Well, see,
Because
because
Wow.
yeah,
Okay, well.
because you have a number that's something so fundamental as Euler's formula, which is just the infinite.
Oilers,
It's a-
Oilers.
you
Yeah.
just
Well,
hey,
I'm
yeah.
never gonna remember him as that. So you take something like Euler's formula, and you have a the imaginary number, and Euler's formula is irrational infinite, and you have something like tau, which is just a really important number in and of itself because it's it's come through the circle, and then that's 1. That's really cool.
Yeah. So just this is why I love
¿Qué
this.
casualidad?
Yeah, el mundo es un pañuelo. You guys have to leave.
Yeah.
Okay.
Yeah.
Well,
Alright.
you can see the rest of it online.
Oh yeah. Okay. All right.
Yeah.
What website is that uploaded?
Hopefully the Invisible College website, although it may take a while.
Okay.
Yeah. But
Pretty impressive.
yeah. So see you guys later.
No, do you want to take a break and continue the lecture another time, or you want to finish? How much longer do you have?
Let's see. What slide are we on?
I'm going to pause this. How do I pause this?